Hello everyone. Am I audible? Okay. And the slides are visible as well. Okay. Wait for a few minutes more. Let us see how many people join, and maybe around 7:10 we will start.
Yes, yes. Yes, you are audible and visible.
Yeah, we will start in 5 minutes. I'm waiting for others to join. So let us start. Um, no one else is joining. So we are in the third week of the Natural Language Processing course of NPTEL, and this course is taken by Professor Pawan Goyal and from the Institute of Institute of Technology Kharagpur. And I am Punyajoy Saha. I will be taking this problem solving session. So here is the first question. So this is a big text about on extractive summarization. So the content is not that important, but let us try to see the question and then we will come back to the content. So then the question is which of the following is correct. So whether the first option is correct, the second option is correct, and third or fourth is correct. So the question is P continuation and is to compare P continuation and P continuation in. So can anyone tell what is P continuation this value? What does it represent? What does this value represent? Hello. So, okay, so this value present, how many times does W appear as a noble combination? So this is directly proportional to such Wi minus 1 cases where C Wi minus 1 comma W is greater than 0. So uh, wherever this W appears, we have to find Wi minus 1 comma W, and if Wi comma 1 Wi minus 1 comma W is greater than 0, then that is one unique combination. Okay, so let us go back to the passage. So can you tell me where we are seeing the unique combination? And let us mark those places. Where do we see the unique combinations? Let's say for AND, can you tell me where the first combination is there? So AND should be, so there should be a word before AND. So where can you find that in this text? Can you tell me one of them? Am I audible? Okay. So let us see where you can find that. So this is AND representative. So this is one example. This is another. So these are the 5 cases where AND is there. And in and then followed by something, some words. And similarly, there are 4 cases where in is, but we only have to consider the noble combination. So this and last is same, so we'll consider once. Hence, both these values are same. So by this formula, the P continuation W is directly proportional to this value is same for both these cases. Hence, the answer is C.
Excuse me, your voice is breaking.
Hello,
Your voice is breaking sometimes.
is it better now?
Okay,
Yeah. So did you get it?
that was fine that I got.
Now let us move to the next question. So, uh, so here you have given an article, and then you have read that words sentiment, aspect, and opinion occur 5 times. Triplet and extraction occur thrice each. Pointers, decoder, encoder, decoder network and occur once each. Now they are asking you to find out the MLE and the good Turing estimate of reading architecture. So can you tell me what is good Turing estimate and why is that? So this is good Turing estimate is one type of smoothing. So why is any type of smoothing required? Why we cannot like go with the traditional MLE framework like MLE estimate? Why is smoothing required is the current first question, and then we can go to what is good Turing estimate. So why is any type of smoothing required? We can directly use the maximum likelihood estimate.
Don't know.
Okay. Anyone else? Okay. So the main issue is that when, so for example, this word. So this word is you do not have this word in the corpus. So you do not see this word in the given question. Basically, this word is not non-existent. But so if it is non-existent, so that we will answer like the MLE will be 0 because the count is 0. But this can, so what happens in traditional systems that you have a trained data set where you have to like calculate this maximum likelihood, and then you have to like just predict it in test data set. So now let us say the architecture word is only occurring in the test. So you'll automatically assign a zero probability to that, but that may not be correct. Hence, we apply some smoothing techniques to get a better estimate of the probability. So that is why any kind of smoothing is required. Now coming to the good Turing smoothing, so it is based on this formula. So this P star GT thinks with frequency C equal to C star by N, and C star is represented by this formula. Here, since we don't have the architecture word in the corpus, we will use a more simpler version of that, which is P star GT N1 by N, since the C is equal to 0 in this corpus, which is N1 is the total number of unigram by the total number of all the words. So now can you tell me what will be the answer for this? So you have to count the number of unigrams divided by total number of words.
Aren't they the same unigrams and number of words?
Aren't they the
Same unigrams and number of words.
no
I'm
number
not
of?
asking in the context of this question. I'm asking generally.
I did not get your question. So aren't the unigrams?
And number of words the same.
No, unigrams. So I am
Because
saying.
unigram
So
means one word. That's what I mean.
I am saying okay, occurrence. Sorry. So I am saying the frequency. It is not unigram. Like unigram is same. I am saying frequency of a particular word. Yeah, that is not unigrams. Yeah, so you have to take the number of words which are occurring only once. So what will be the good Turing estimate based on this formula? N1 by N. So let us try to solve it. So first tell me what is N? What is N? Can anyone tell what is N? So for the ones joining now, we are trying to use this formula, this good Turing estimate for C is equal to 0 case, where N1, so the formula is N1 by N. So you have to find the total number of words that appear in the training by the N1 is the total number of words which appear once by the total number of words. So can you tell me what is N here?
And it's 25.
Yeah, how did you do that?
Just basic.
Yeah.
3 words 5 times 15.
And what is N1? So there are three words with 5 times, so it is 5 into 3 plus 2 words, that is 3, there are 3 times plus 4 words that are 1. Okay. Now what is N1? This is again pretty simple, right? 1 is 4 here. The answer is B. And Emily we already discussed, so Emily is 0 because 0 by 25 because
Actually, you are not audible. How did you get N1 is equal to 4?
so N1 is the number of Number of words which are occurring only once. Did you get it? Hello?
Yes,
Okay.
got it, got it.
So that is the correct answer. Then moving on to the third question. So here also we are provided a corpus, and we are not provided like the overall corpus, but we have provided some counts. So they are saying that in the corpus there are 5 words A, B, C, D. E. So these are not characters but words, and you are provided the following count. So we are provided with the trigram, bigram, and unigram counts. Okay. So now already you know what are these n-grams like bigram, trigram because we are already discussed. Let us move to the second part, like the question. So they are asking us to use a linear interpolation based language model to estimate the trigon probabilities. So the basic question is what is linear interpolation and why it is required? Can anyone tell? What is linear interpolation? These are already covered in the lectures, right? Based upon unigram and bigram probabilities. But this is still incomplete. So can you explain a bit? What are you trying to do based on unigrams and bigram probabilities? Hmm, else? Okay, okay. Let me go forward. So what happens is, so first of all, this is the interpolation part. So to calculate the trigram information, trigram probability, we are using the bigrams as well as unigram probabilities. But the question is, why should we use it? Can anyone guess like why this can be required? So we already have the trigram probabilities in like we may have the trigram probabilities, but we are also using the bigram and unigram cases. So can you guess why that is done? So this is the basic idea behind interpolation. It is very simple. But why do we require that? If you don't know, just reply that we don't know.
Don't know.
Okay. So what happens is in any so let's say you are reading the first 50 words of a corpus. So now it is possible that we will not see much of the trigrams till then, but we will see much more bigrams and unigrams, and we have some like better estimate of these things. So if we want to calculate those things in between some corpus or when we are don't have much data, so it is found out that we cannot only rely on the trigram information because that may change like drastically when we are reading the whole corpus. That's why it is better to use some interpolation techniques so that we can get a better estimate of what is this trigram. So this may not be the actual like the probability when we read the entire corpus, but it provides a good estimate of that. So the basic idea is, or the basic,
So if the corpus is large, does this equation holds?
if the corpus is
Large.
yes,
Do we
so
need this equation?
Yeah, the corpus can be large, but I am saying, let us say you are only like looking into the top 50 words for now. When you are starting the MLE or starting the probability, trying to find the probability, you are only looking at the top 51. So then it is better to use this kind of interpolation to get the estimate. But if the corpus is large, then this don't hold much value. So as you will see, like then the lambda values will like prefer the first trigram than the rest.
And what is lambda value? Is it the weights given to the data?
Yeah, so that is the weight. So if you have enough data, then you can like specify that lambda, the first lambda can be higher. So let's say 0.95. But when you have less data, then it can give higher weightage to the other categories.
And how is it calculated? Is it similar to linear regression model or something like that?
No, currently, so we are setting the lambda based on. So the only criteria here is lambda I summation equal to 1. So in general, if you are talking about the question, solving the questions, you will receive this lambda values in some form, and then you have to calculate. Let's say you are given two values, like here. So you are given bigram and unigram values. So you need to calculate the trigram value. So that is very simple based on this formula. But usually we are setting the lambda value so that we get a better estimate. So that is for this case, like the simple interpolation. Okay, so let us go forward. Now, so the basic idea here is that whenever you have less data, you try to use less context. Or when you do not have learned much about the larger context, then you use less context. Okay. So now again coming back to the question, the question is that we have to find the p interpolation of wn given wn minus 1 comma wn minus 2, where wn can be any of these three a b c d e, and wn minus 1 equal to a and wn minus 2 is equal to c. And we have given the point, we have been given the bigram and unigram weights that we have to use, and we can easily say that the w1, that is the trigram weight, is zero 0.7. So that is what I have done here. So uh, so lambda 3 equal to, so the first information that we need is the lambda. So lambda 1 is equal to 0.7. So now we need to calculate the rest things. So let us first do for one case. So let us say sorry, PA given wn minus 1 is A given AC. This interpolation you have to find. We are doing it for the first case, that is the A, wn is equal to A. So what will be the formula? 0.7 into 0.7 into 0.7 multiplied by, can anyone tell? 0.7 multiplied by this m, right? A by AC, then plus zero point 0.2 multiplied by, is this clear? And finally 0.1 multiplied by, yeah. So is this line clear for you?
No, Wn has been given as A, B, C, D, E. You
Yeah.
have just taken the
So we are
numerical
solving it for first A. So if you see the question, yeah. So you have to do it for each of these values. A, B, C, D. So we are solving it for the first case.
Okay. Got it.
Yeah. So this is clear, right? So this is how we are doing it.
Yes, sir.
So then we have to basically put the values. Now 0.7 into multiplied by. So now let us look at the table. Table. So C followed by A followed by A. This is the case that we are looking at, right? So A is the Wn word, Wn minus 1, Wn minus 2. Yeah, so this is the word we are looking at, and its count is 0. So what will be this value? The A given AC. That would be 0. So whatever the denominator, it is not important. Then zero point 0.2 into A given A. If we look at the value again, it is also 0. So we will replace it in, like, we will add 2, 0. And finally 0.1 into P of A. So what is P of A? So can you tell what is P of A here?
10, 10,
Yeah, P of A is 10. So 10 is the count. And how many total words are there? Like
20, 50.
yeah,
10 by 50.
1 by 5.
1 by
That is zero point 0.2 into 0 0.1 equal to 0.0. Now let us try to solve for. So this is everyone got this part, right? If not, please tell.
Yes, yes.
Yeah. Now let us try to solve for Wn is equal to P. So I am giving you, like, let's say 5 minutes time to try to solve it. So everything is similar, just you have to change the values. And I am like focusing on this table so that you can refer. List of options. So Yeah, Suraj, so we will take this maybe after this session because we are now discussing week 3.
Okay, sir. Okay.
So just stay
But
back
means
like 5 minutes after the session and then.
okay.
So now try to solve this question.
Yeah, sure, sir.
Yes, anyone got the solution?
Hello, sir.
Yes. Yes, sir.
Actually, I joined late, so here I think here we have to find a trigram, yeah, related to word A, B, C, D, E.
So, okay. You can wait for a bit. Let others solve. Then I can discuss. So has anyone solved?
Yes, sir, I did.
Yeah. So what is the answer?
Sir, for the answer A is it is
So we have to solve.
0.02.
Yeah, we have to solve for B. So A I already discussed. Now we have to solve for Wn is equal to P. See the chat window.
Okay, sir.
Same thing, but for Wn is equal to P.
Yes, sir, I got the answer. 0.3665 for B.
Okay. Anyone else got different answer or the same answer?
0.38.
Okay. Yeah, anyone else? Can you just write the answer so that? Okay. So you have got 0.365 and 0.38. One else? Okay. Let's try to solve. Yeah, so Suraj, can you tell what will transformability?
Yeah, sure, sir. So it is 0.7, 3 divided by 8,
Right.
and plus 0.
3 plus 3 is 6 and plus 0.2 into. Is that right?
4 by 10,
Okay. 10.
and then point 1,
uh,
12 by 50.
12 by 50. So, so another answer was, how did you get 0.38? This is the correct answer. But I want to know, how did you get 0.38, and then we can discuss what's wrong. Or did you, sorry,
Hello, sir. Hello. Ha, yes. Because lambda 3 is 0.1.
so this is the correct answer, but like, how did you get 0.38, and did you understand this? Rajit, can you please tell me, say?
It's the same thing. Maybe I just rounded it up.
But then also it is like 0.3. Okay, I guess you rounded it in. Fine, fine. But do not do it like, so the best strategy to follow is round it only after you calculate the whole thing, not in this.
I rounded it before itself.
Okay, so I guess you are more. So did others understand how did you calculate the answer? So now you can do it for the other three cases. CD, for the sake of time. So this is the way we have to do it. Any more questions on this part? So this is the correct answer. Yeah, let us move to the next question. So this is Nason-Nay smoothed probability. P, K, and B count by A. So this is again another. Sorry. Yeah, so let us move to the next question. So here we have to find the Nason-Nay smooth probability. This is another smoothing technique, and there's a formula for that. So let us first look into. So this is the formula for Nason-Nay smooth probability. So what does it say? So maximum of so D here is a constant. So first we have to calculate the maximum of this value. by C count of W by I minus 1 plus lambda into W I minus 1 P continuation W. The continuation already know, that is the number of novel continuations. That is based on the first question. And that lambda Wi minus 1 is again B by C Wi minus 1. Okay, so let us try to find out this one. Yeah, so first let us find out P. So what will be that? So this is again based on this context. We have to find Wi here is Y here is P. We have to find P continuation. So let us try to do this. So what was P continuation and that was this one. So how many times does W appear as a novel compound? So Wi minus 1 comma W. So we found out that yeah. So what will be P continuation? Where B is appearing as novel compound in a bigram. So how many cases are there where B is occurring in a bigram?
4/10.
I am saying novel compound. So, so we have to find where it is novel. So if there is one AB, so the next AB is not unique, right?
Okay.
So that way you have to select the types. So the total types by where B is occurring, that will be like 1 by 3, right?
Hmm.
There are 3 types where it is occurring, like count is greater than 0. Out of this, one is where B is. This is we are considering only for the bigram. will be 1. Now let us calculate lambda by minus 1. So 0.7. So this will be I plus. Yeah, so we have three diagrams here, A, B, A, C, E, and one is the CA part. That is also appeared. That is not given. That is, but what will be lambda? So here lambda W I minus 1. A. Count of A. How many times A is occurred? This one. See, count of beta. Correct. Beta. Okay, C, so C of A is 10 into, so C A comma W is greater than 0. How many cases are there? A comma W. Comfort. Three cases. This will be 3. Finally, you have to find this one. Here, that's of PWI minus 1 E by A minus divided by CA. What is CA? 4. Yeah, so if we calculate this everything, like put it everything fine. Okay? This has that point 3. Try it once and see if you get this. But did you get the like the how we did the solution? Do you have any doubts? Okay, let us move on to the final question. So this match the following words with the type of morphemes they contain. There are 4 words, and we have to match it with is only derivational, only inflectional, or two. So, what are derivational words? That creating new words by changing parts of speech, and what is inflectional? So, changing the grammatical each of them. So, here the correct answer is C. So, the solution is uplifting is up plus bring plus ing. So, this is inflectional. Regularity is regular plus ity, the derivation, and similarly others. This answer. Okay, so that brings us to the end of this session. So as usual, videos will be recorded in this channel. Slides will be uploaded here. And I have also pasted the same links in the discussion forum as well. And if you have any doubts about this session, you can ask the question in the discussion forum with the particular week and my name as it is. Okay, now coming to it. So what was your doubt?
Hello, sir. My doubt is about week number 2
Yes.
on question number 8.
Week number 2, question number 8. So this is you are talking
We,
about the previous assignment
yeah.
or this like the current assignment.
Current assignment, yeah, current assignment.
Okay, so for the current assignment, I have not yet like I am not the correct person to like answer the question, but I will try to look into it and answer you. You can,
Okay. Sir, actually, I have solution as well, detailed solution. I have only doubt is that there are 7 words, but here it is counted as 6. How? That's I want actually.
so what was the question? So that I am
So the question is given the same language model. Sorry, what is the perplexity of a sentence? And the sentence is Amar is reading a book. So we have to find the perplexity. So
yeah,
for
but this is already I think